Alluvial fan is a sediment that deposit in a fan shape near the foot of the mountain. So it is not a single depositional environment. Actually, alluvial fan has multiple depositional environment combined. So if you think about it, near the mountain, and when sediments are transported within the mountain valleys, they have a relatively high energy. Once they reach to this open area, the sediments, the transportation energy is going to decrease dramatically. Therefore, the sediments start to deposit in this area, and due to the transportation is not confined, so the sediments can go all directions in the open area and deposit sediments in a fan shape. And because the energy is decreasing from the very top of this fan is called apex, decrease from apex to the distal area of the fan. So if you draw a cross section from this apex to the distal part of the fan, we can see a transition from coarse sediments to fine sediments over here. This is due to the transportation energy decrease from the mountain to further into this open area. And from here to here, because the sediments are different, so the depositional process are different, and therefore the alluvial fan depositional environment actually is a combination of multiple depositional environments. In that case, alluvial fan actually can have gravity flows and stream flows. Remember, in the second or third chapter, we talk about the gravity flows. And gravity flows including landslides, debris flows, and mud flows, and the sediment to water ratio is decreasing from landslides to debris flows. So there are three types of gravity flows listed over here, and also the alluvial fan can include stream flows, sheet flood. So the stream flows actually is either a braided river system or a sheet flood. The difference between those two is that a braided river has confined channels, while sheet floods does not have confined channels, so it's just go everywhere. Okay, so there are two types of alluvial fan. One is called debris flow dominated, and one is called stream flow dominated. So debris flow or gravity dominated alluvial fan. It's just dominated, but not saying that one alluvial fan could only have one type of flow that is depositing sediments. So in all alluvial fans, in all alluvial fans, they could have a gravity flow and a stream flows. And just think about it, one alluvial fan could have gravity flow dominated, could change to gravity dominated flows deposition during a storm period or rainy season, while during the dry seasons the alluvial fan can be dominated by stream flows. So this is a picture showing the sheet flood. So as I said, there's no confined channels, and those are confined channels. Those are deposited with confined channels. Okay, so debris flow dominated alluvial fan is the sediments are characterized by debris flow. And just remember, trying to refresh your memory that a debris flow, what's the characteristic of a debris flow deposit. So first, the debris flows deposit conglomerate and breccias, and then that's the texture that is dominated by gravels and sand and with mud as well. So it's a mixture of everything. The sorting is very poorly sorted. And then does debris flow has any textures? There's no unidirectional flow textures in debris flow, so you are not going to find cross beddings in debris flow. Then, but in debris flow, remember there's a very particular structure in debris flow, that is the reverse grading beds, because the sediments and sediment to water ratio is very high, which means we have a high sediment capacity in the debris flow, and when it flows, because of the dispersive pressure, it push the bigger sediments, larger coarse sediments to the top. So when it deposits, it has reverse grading sediments, reverse grading beds. That is very diagnostic to debris flow, but the reverse grading beds is not always appear in debris flows. Okay, so here I want to show you that debris flow, so how this fan shape was developed is that debris flows, when the sediments reach to the apex first, then which way it goes, it always goes to the steepest slope. So then it dumps a bunch of sediments over here, and then once the sediments start to deposit over here, this path become no longer the deepest slope. Then probably somewhere over here is steeper. The debris flow gonna switch to this side and dump another lobe of sediments. And then this area is not the steepest slope anymore. Then it goes to this side or this side. So gradually, this fan-shaped deposit developed. It works with the stream flow as well. So the fan shape is developed due to the switch of the channels. This picture shows the deposit sediments of a debris flow and a deposit of a something in between of a debris flow and a stream flow. So debris flow is characterized by high sediment load within the flow. That means the sediment over fluid ratio is very high. And so the grade beds grading is depending on the dispersive pressure sorting, which is the pushing the larger size grains on the top. So this is a dispersive pressure grading. On the other hand, the stream flow deposit, which is dominated by braided stream flow, it is a hydrologic sorting process, and usually the deposit is normal grading beds, which means the larger grain size is on the bottom and the finer grain size is on the top. And this is only based on the hydrologic sorting, which means the higher energy carrying large grain sizes, smaller energy carrying finer grain size. So alluvial fan deposit, usually we see alternating of debris flow and stream flows. So debris flow can also deposit a massive conglomerate or breccia. So the stream flow over here usually develop of hydrologic sorting, which are represented by the stratification, cross stratification, or trough cross stratification, or sometimes if the flow energy is lower, then we probably also see cross lamination in the. And down here, these are surging debris flows, which means the debris flow episode is even more frequent. So, and then there's also a type of fluvial sediments flow. So even in debris, this is dominated by a stream flow alluvial fan. Even though they are a conglomerate deposit, but you can see the conglomerates actually lining towards one orientation, and these are imbrication structures. So you can see imbrications in conglomerate. Then it is an indicator of hydrologic sorting. Okay, so this is a picture of alluvial fan deposit. So when I say alluvial fan, actually it is a secondary interpretation. The first interpretation are these beds that this is a debris flow deposit, and this unit looks like a stream flow deposit. So you can see channel scours over here. This looks like a braided river deposit. So it is alternating from braided river, braided stream deposit to debris flow deposit, and then to braided stream deposit again. So when I say it is a braided stream deposit, this is the primary interpretation, the first order interpretation. Including the braided stream and the debris flow deposit. This is actually a interpretation. And then the secondary interpretation is based on this large unit of deposit. The entire unit is very large in this region, and then it is alternating from this braided stream deposit to debris flow deposit. It is alternating beds of braided river stream and debris flow deposit. Therefore, based on the understanding and combined, and it is a large unit in a large scale, probably the whole region, that in kilometer scale, the region has a deposit like this. And so then I can make another interpretation. That's the second order interpretation, that this is a alluvial fan deposit. So here are more pictures of alluvial fan deposit, but these are just, if we see these pictures or these outcrops in the field just by the single location, we cannot interpret it as a alluvial fan deposit. We have to go around and see it is a large scale deposit that we can infer it is a alluvial fan deposit. But just based on here, it is a conglomerate deposit, and I cannot even tell is it a reverse grading or massive conglomerate. Just based on the picture area, what we can see, it looks like a massive deposit of a conglomerate. So in this comparing these pictures, if these are deposited from one single alluvial fan, then I can say that this is a location that close to the apex of the conglomerate, while these two probably at the distal area of the alluvial fan. So this is near the apex of the alluvial fan, while these two locations probably will be further away near the edge of the apron of the alluvial fan. Alluvial fan depositional system is sediments that deposit in a fan shape near the foot of the mountain. So the mouth of the alluvial fan is called apex. And alluvial fan deposit is not just sediments coming out from the apex and deposit all over the places. Actually, the development of alluvial fan is a progressive process that it can, at the beginning, it develop a lobe of sediments like this, and then this side, the slope of the topographic slope increases. So then the next episode gonna deposit another lobe over here, and then the next time is switched to this side. The next time is switched to this side, and then next time when it comes over, then probably inside and like erode some of here, like, or we say the incision happens on top of these, or it just keep going, keep great, or it just keep aggregating over here, or keep propagating this way. And then the next slides is going like this, and then it grows this way, and then it grows to this side, and then eventually more lobes deposit. And so building a alluvial fan is a progressive process that it grows. The different lobes represent the different episodes of deposition. And from the apex to the distal part of this fan, the texture of the sediment is gonna change. So if we draw a cross section from A to B, then mostly we will have from A to B, we will have a slope change, and the slope goes in this shape instead of this shape. So, and from the apex, grain size are actually larger. And then you can see a grain size gradually change from coarse to fine. And if we draw a cross section from C to D, then the shape, I will just show you the shape C to D. The topographic shape will be like this. And the grain size actually varies along this grain size. Actually, this is the distal part of the fan, so have greater grain size. In the middle probably, and then smaller size on both sides. Okay. So, and the depositional process of in this alluvial fan varies as well. So I'm not saying that all alluvial fans should follow the process I'm describing later, but what I'm saying is just a general trend. So if we divide the alluvial fan into 3 portions, then the first portion here will be near the apex will be dominated by debris flow. So depositional process within an alluvial fan are different within. So depositional process within alluvial fan varies from the apex to the distal part of the fan. So I'm not saying that these lines are definite lines and differentiate the depositional process in each part of the alluvial fan. But what I'm talking about is a general trend of depositional process within this alluvial fan. And for specific alluvial fan, there are debris flow dominated alluvial fan, stream flow dominated alluvial fan. It varies from place to place, but in general, an alluvial fan, near the apex, the depositional process is dominated by debris flow, and within the middle part, like further away from the apex, then the depositional process is going to transition into dominated by stream flow. And at the distal part of the fan, it will turn into sheet flood, which is the difference between stream flow and sheet flood is that stream flow is mostly braided streams, and there are channels within braided stream, while sheet flood does not have any channel. So it's just there's no confined channel and deposit. The sediments just go flatly to a flat area and deposit like that. Okay, so let's talk about debris flow. So a debris flow deposition is characterized by mostly conglomerate deposit. So let's draw a conglomerate. And the conglomerate can be massive conglomerate, can be matrix supported or class supported. And debris flow, there's another characteristic deposit that is conglomerate but with reverse grade bedding, so that the dispersive pressure makes the larger clasts on top and then smaller clasts at the bottom. So it's a reverse grading bed. And also just remember each episode of deposition is separated by an erosional surface. So then we'll probably have another episode of debris flow. And because this area dominated by debris flow, it also could have a braided stream deposit. So there may be a thin layer, a short period of time that debris flow deposit over here, and then on the top will be more conglomerate. So this is the debris flow deposit, and near the proximal part, it's the proximal part of the alluvial fan. Then how about the stream flow? Stream flow is dominated by braided stream. So this place can be characterized by braided stream deposit. We just talked about the braided stream deposit. So in general, braided stream deposit has cross sections, cross beddings, and then another episode of cross bedding with erosion surface at the bottom. Could have trough cross beds and cross stratification, and maybe a layer of mud. That's a weakly developed floodplain with the soil. And then another episode of sandstone, gravelly sandstone. Maybe some ripples. Okay, so this is the middle part of the alluvial fan. And then let's see the sheet flood. So sheet flood is characterized by poorly sorted sand or mud deposit. So just think about the process. Think about the depositional process, that a lot of sediments that are coming from the mountain and carry past this area, and most of the gravels has dumped over here, and then the sand, mud and the sand will carry on and deposit at this place without any channel. So it's just flat and spreading. So we will see laminations. So we will see laminations, right? And then another episode coming on top of that, will that be erosional surface? No, because there's no channels. So usually there's a confined stream and will erode the previous sediments. But there's no confined stream, sediments just laying on top of another, laying on top of it. So there will be the grain size probably change, but there will still be layers like that. And sometimes there are cross-bedding structures you can see, but mostly it's like that. Okay, so see another beds of lamination. And sometimes we have a muddy layer as well. So, we discussed the debris flow and the braided stream and the texture structure. I'm not gonna talk about here, but here for the sheet flood, I want to say this is in terms of texture. So it's dominated by sand and mud, and it's poorly sorted. So because it's poorly sorted, angular to subangular. Why is that? Because it's still near the mountain area and the sediment has not been transported for a long time and a long distance. So the sediment will be character, even though it's just sand and mud. The sand has various grain size from very coarse size to very fine sand. The grain size can vary. So. And then the texture has a poorly sorted and angular, subangular to subangular, all because of it's near the source area and transported only for a short distance, relatively short distance, and a short amount of time. Structure will be lamination, or stratification, and with maybe sometimes with a crossbed, but not often seen. Okay, so this is the characteristic and the typical stratigraphic column for different areas in a alluvial fan deposit.